Hello, and welcome to Technically Speaking, where scientists and engineers come together to chat about a common interest, share knowledge, and satisfy some curiosity. I'm Antonia, and I'm joined by Jasmin and Laura to talk about chemicals and testing toxicity before they are put into products. So, Laura, you brought this topic up. What was it that you read?
How do you know I was reading something? It's how these things usually come about. Yeah, so I was reading an article about how manufactured chemicals have led to an increase in childhood diseases.
That doesn't sound good.
No, it was authors of a study in the New England Journal of Medicine, and they're calling for chemicals to be tested before they come to market because in the United States, what they do is simply presume that all manufactured chemicals are safe unless they're proven that they're not, which I personally find a little bit weird.
It's the opposite in Europe. You have to prove it's not harmful before you can introduce it.
Exactly, and that's what I'm used to. But it did make me wonder about how chemicals are tested because our bodies are really complex and there are probably thousands of ways that a chemical could cause disease like cancer or harm some other way, like just asphyxiating you. So it just made me question, how do we know something is safe essentially?
That is a really good point. And like Jasmine said, you would think things are tested before being used, but there we are. Jasmine, I guess you might know more from this because of your chemical engineering background.
I just about remember what a risk assessment and a COSH are.
It's control of substances hazardous to health, isn't it, Kosh?
Yeah, it is. It's what all workplaces are required to complete if there is any chemicals that workers could be exposed to, and then how they're going to contain it so that workers don't get exposed to it or exposed to whatever the legal limit is.
So that seems like a good measure to have, especially if people are probably going to work with the chemical before it becomes a product. So, Laura, you looked into something similar, though. I remember there was an episode we had on drug safety.
Yes, so I also had a thought about how do you test a drug to make sure it's safe? What step to get it to market? One step in the process is that experts essentially use their own judgment to weigh up the pros and cons. After usually some modelling has been done, the drug has been tested on animals, and there have been clinical trials on people that are in as controlled manner as possible. So there is like kind of multi-step process to see if something is dangerous or not. And then even after a drug is brought to market, they still look at what happens when it's out there in the wider world and a larger number of people are exposed to it, and they're constantly updating whether something is safe or not. So essentially, it's a massive, long, multi-step process.
I don't have much of a biology background, but if I get a new medication and read the actual leaflet that comes with it, it actually comes listed with all the different side effects and the likelihoods based on, I presume, data that they've gathered. And even if you get a new one, they'd even say, here's how to tell us about this new side effect you've had so we can keep updating it. So yeah, it's great that we have got control measures and also continue to review the medicine.
And I think the key point is before it gets to that stage, it starts off with testing in a lab on, I guess, non-human subjects. So there's still an element of, is it safe to proceed to the next stage of testing on people?
Yeah, and we talked about how drug development is very expensive because there are all these stages to it. I suppose it is different for other products though, because drugs are usually, not all, but usually pills or something that goes into the body like a nose spray or eye drop. Eye drop.
Or an injection, yeah.
So yeah, because these drugs come in doses, I suppose that's one of the ways to control it. We have a controlled amount of exposure, essentially.
Yeah, so you mentioned having a controlled dose. And I know from working in a science lab that you have safety data sheets for most chemicals that you use, and you have to use those as part of your risk assessment. So I did start to wonder, do these exist for things that you don't usually use in the lab that you might use at home? And it turns out, yes, you do. I found safety data sheets for household bleach and for a type of waterproofing spray that you can use at home to reproof your waterproof coat. They sort of list what the basic components are, whether these things are hazardous or not, the types of hazards you expect to see. Some of them also list short and long-term exposure limits. So again, there's a dose component in there. So you can be exposed to so much before you have to start wearing safety measures like a respirator or gloves.
Interesting.
Yeah, and The spray-on waterproofing isn't classed as hazardous, although it does say you should wear PPE if you're going to be exposed to it a lot. Safety measures, I should say. Bleach, unsurprisingly, is considered hazardous. And I think what I find interesting about that is that we have this really hazardous product in most of our homes. And the safety protocol apparently is to keep it locked away. Who does that? Has anyone actually locked their bleach away?
You would if you have small children.
Or you're supposed to.
Yeah.
I think most of the time it's just under the sink cabinet and maybe at the back. None of us have children.
You two have pets.
To be fair, I do keep chemicals out of the way of the dog if I think he might go for something. So plastic bottles I know he's fine with, but if it's just sitting there in a bag, I doubt he would go for it, but I still move it out of his way.
I have locked away a certain cupboard, but that's because it's got treats in it.
It's the opposite.
And Buffy opened the cupboard, so then I put a child lock on it. But anyway.
Yeah, getting away from talking about children and animals in the home. The safety data sheets I was looking at, some of them did have toxicity limits on them, so they must have some sort of, I guess, standard testing for that.
Yeah, there are standards for testing toxicity of chemicals. The global one, I believe, is produced by the OECD, or the Organization for Economic Cooperation and Development. They have a set of guidelines on different testing that you need to do for different types of chemicals, for different exposure pathways, so exposure to like humans, to water. In Europe, there is a standard. It's called REACH, and companies have to prove that existing or new chemicals that they've developed are not harmful before it can be introduced into the market.
Do you have any idea if that's similar to how drug development is done, where they might model it and they'll test it on animals? So I'm guessing they just, I hate to say this, feed enough to a rat until it dies and then figure out what the lethal dose is.
Yeah, that's pretty much what they do.
God.
So, like, for the different toxicity exposure, so like LD50 and etc., there are different tests.
The LD50, that's the lethal dose to what, 50% of the population?
Yeah.
So only half of us will all die if we do this thing.
Yeah, there's different tests for how you determine that. It's generally mice, rodents, that are used in these types of tests, but there is an interest in shifting towards alternative methods, so using like cells, or trying to use DNA instead of like testing on animals.
Oh, interesting, because I like that idea, but then there's a lot of conjecture about whether testing just a cell or even an organ out of the body is the same as testing it on the organism itself.
Yeah, there is. For toxicity to plants, you would just expose seeds to the chemical and then see what happens when it grows.
Is that because it's probably quicker than trying to see what happens to an already established plant?
Yeah.
Because I can see that I was going to say an adult plant then, and I don't know.
Established?
Yes.
Mature?
Thank you. Like, if it's got loads of leaves, some of those leaves will probably still survive, and it could have mechanisms where it can, I don't know. You hear that trees talk to each other, don't they? So if one of them gets a disease, it releases chemicals into the soil that all the other plants then react to, so they sort of protect themselves.
I had no idea that they did that.
Yeah, they've got defense mechanisms. There's a whole chemical signaling pathway going on in the soil.
Wow. Yeah, so going back a bit, we were talking about chemical safety tests on like living beings. Well, plants are all, yeah, animals. But it's a bit late, looking at it once the effect has happened. So is there something we could have done to know earlier? Something I was reading from a toxicologist on social media called Mo Skin Labs. He works in this area, and what they would do is first assess if this new chemical is chemically similar to any existing chemicals with safety information, and they would sort of look at what it reacts into, so like what are the reaction pathways, chemical structure, so what's the active part of a chemical that does the thing, like you sort of see active ingredients, but within a chemical, if it's just got a long chain, but then it's only...
The functional group on the end, if you're a chemist.
That's the word, functional group, thank you.
The bit that does the stuff.
Yeah, the bit that does the stuff. You would then actually continue that thought path. Sometimes, even if you did those first two things, they don't always result in the same toxicity, because it then depends on absorption rate. How does it penetrate the skin? How does it interact with water? and that could also change its toxicity.
Oh, so it's not enough to say, well, chemically it's very similar to this other chemical, so we think it should behave the same. It might not, even though it's only very slightly different.
I suppose that's why the standard is to actually like test the chemicals individually.
Yeah, I feel like the approach that Antonia's mentioned should eventually become a thing, because we already have this quite large body of knowledge about what chemicals do. And it's not complete because, as I said, our bodies are really complicated.
Yeah.
I wonder if this is something that artificial intelligence, or machine learning, if you prefer, because it's not actually intelligent, if this is something it could help with, because it's essentially about spotting patterns, isn't it? Which is what machine learning does.
Yeah, potentially, because they're of the chemicals that are manufactured, so like not naturally occurring. There's like safety data. So like is it corrosive, is it explosive, etc. But there's very small proportion that has actual toxicity data, because that kind of testing is really expensive.
Because you have to test it on, I guess, a large group of animals.
Yep.
And I suppose a lot of chemical manufacturers might say, well, no one is ever likely to eat this or stick it in their fish tank. So do we really need to test it? Just put a warning on it saying do not ingest.
Well, that's an interesting thing, because I suppose things do eventually end up in water and soil. Because even if it was on us, we might wash it away, or it gets processed through the body, or it might not get processed through the body, and then end up in our waterways.
Yeah, it's a bit like microplastics is a really big issue now, because like you're not going to stick like a chemical safety label on like a plastic bottle, but the microplastics are quite bad.
And I guess that's what the authors of that article I was reading about in the medical journal were trying to get at, that you need to make sure that things really are safe, because even things that you think are fairly benign like plastics, it turns out have quite terrible consequences. But then how do you test for everything if we don't have a complete knowledge of how everything affects us? I feel like I'm just kind of going around in circles for my own question here.
Yeah. So, yeah, we've sort of covered safety tests on animals, but they're sort of just instant death situations. But what about more long-term conditions like bioaccumulation? Could we have foreseen that mercury and lead and other heavy metals accumulate in fish the higher up in the food chain they are?
See, when I started reading into that, I think that was only really discovered in like the 1950s. A lot of this seems to be a result of the first industrial revolution. It's the Victorians again, they're responsible for everything that's terrible, it would seem. But that's when we started doing things on a bigger scale, isn't it? And moving things around the world. So it stands to reason that's when we started noticing the effects we were having on the environment. But if it's a relatively recent thing, then I'm not entirely sure how we would have had the knowledge to be able to predict that until it happened. That's a strange sentence. You know what I mean?
Yeah, we just didn't know it was a thing. We didn't know what we didn't know.
Exactly.
But now that we do know what bioaccumulation is, and that is a thing, it is something that is taken more into consideration, especially with microplastics, because people are trying to do some research on what are the impacts.
Yeah, and then I always think, well, so what? Because isn't plastic biologically inert? But then if it just sits in your body, does it break down to give off things, or does your body react to it in a strange way because there's a foreign object in there?
Yeah, it may just be like how much plastic can a person ingest and hold in their body before it is hazardous, and then you start having health issues.
Do you become just a plastic person like a Barbie doll?
But there are like some microplastics, they are actually like toxic. So like car tires, when they wear down from like just wear and tear on the roads, and they get washed into like water bodies.
Wonderful. So what if we just didn't use chemicals?
Everything's a chemical, though. I don't see how you do that. Water is technically a chemical.
Well, could we be more cautious? You know, if we know that there could be a potential problem, we just avoid it?
Again, if we didn't know there was a problem to begin with, like with the mercury in the fish, then even though it's been, about 70 years since then, there's still new things that we're learning about, like plastics, as Jasmin mentioned. I wonder, though, if a sensible approach might be to ask, does this thing already exist in nature? Like radioactivity, that is a natural phenomenon. And then are we just increasing the concentrations of that thing, the radioactivity, the toxic chemical, whatever it is? Are we increasing it too much that it's going to cause harm?
There was an instance where there was a lot of concern on just like exposure to radioactive material through fish. So the Fukushima power plant, they had to discharge wastewater, which was tested and did meet international standards in terms of like radioactivity levels. It's normal. Every power plant does this. So they discharge the water into the sea, but China and some other neighbouring countries were not very happy. And China, even to this day, because I think they did the discharge like 2 years ago, maybe more. But China only recently partially lifted the ban on fish and seafood imports from Japan just because of concerns of radioactivity in the fish.
To me, this just seems like one of those knee-jerk reactions to the word radioactivity. It's seen as this human-made terrible thing, even though it's all around us anyway. And the question is it radioactive enough to cause harm? It sounds more like a political thing than anything else to me. I mean, I'm being really pessimistic there.
Yeah, I mean, it was determined that the water wasn't radioactive enough to actually cause any harm to the ocean.
So unless there's something in there that's going to bioaccumulate in the fish, which I'm guessing there wouldn't be if that knowledge is known. Circling back to my own argument.
But to touch on the point that you made, Laura, of just looking at if things are naturally occurring, is that one of the ways we could look at if something is safe? Slightly off topic, because it's, as you know, asbestos. But asbestos is naturally occurring, and you can mine for it, and then we put it into insulation.
But then we increase the concentration of it, I assume.
I suppose, yeah, that's a fair point.
But I feel like, well, it is naturally occurring. It's not something that humans would naturally be exposed to quite often.
No.
Because you do have to dig into the ground to get it.
See, I didn't actually know it was a naturally occurring thing. 'Cause this was a big thing in, like, what was it, the 70s it was used? It's everywhere in my house, Kyle, and I'm slowly getting rid of it very carefully.
That's a scary thought, though, isn't it? You're just surrounded by it.
It's only a hazard if I disturb it, but I am disturbing it. However, I am following safety protocols from the regulators. I'm doing everything right that I should be.
I think so, like, with asbestos, it's naturally occurring with other chemicals and minerals like talcum and, like, some of the calcium minerals. I think there's a lawsuit against Johnson & Johnson because talcum powder, which you can no longer buy now, it's now just baby powder, which is like corn flour, because talc, the mineral, when you mine it, there's just like traces of asbestos with it.
Oh, wow.
Because people use it on their bodies as a personal hygiene product. So there were cases of cancer that were linked to the usage of talcum powder through the asbestos that was in it.
But this is the thing, though. Asbestos was seen as this, like, wonder material 50 years ago because it had all these brilliant properties, like being fire retardant. And then it was found that it caused long-term health effects. Like 20 years after exposure, people were developing cancers because fibers get into your lungs and they don't go out and they just do things that they shouldn't.
Yeah, you say that, but there's still countries in the world that still use asbestos, mostly in construction because it's really good fire retardant. But I guess they have a financial incentive to keep the industry alive if they're a country where they mine and produce asbestos and make asbestos-based products.
And I guess if you've got it as a natural resource and it does have all these brilliant properties, you'd want to make use of it, even though it still kills thousands of people around the world every year.
Yeah, was it like 200,000 deaths globally?
Apparently so. And a fair few of those are in the UK, I guess, because we used it so much. And as I say, even though we've stopped using it so much, it still takes a long time for the effect to be realised in your body.
And have found alternatives, so it seems like it's less of a technical issue, but a political or social will issue to stop using it.
Yeah, and I guess also because the danger isn't immediate, it's long-term effect. It's not like someone's suddenly going to drop dead on the construction site and they've been handling it for a day.
But it's also about the exposure pathway, because asbestos is only harmful if it's disturbed.
But I guess if you're working with it inherently, you must be producing dust at some point. Unless they're wearing respirators, I'm not sure I'd go near it.
So it's a bit of a heavy topic because it is literally products around us every day. There is a clear difference between how the US and Europe/the UK approach new chemicals in products. Where would you rather live?
Because I've worked in a chemical lab and in the nuclear industry and I'm used to how we do things, we're under European UK regulation where you kind of have to prove something is safe or stick warning labels all over it if you're not sure. I'm not sure I like the idea of living in the United States where something is almost assumed safe until it's seen to cause harm. That just seems like the Wild West, essentially.
Yeah, I feel like a lot more people have to find out for themselves and then lobby together to prove otherwise. And if testing is expensive for companies, how do you get a group of people to gather together to arrange that?
This sounds like the plot for Erin Brockovich, that film about a legal team that took on as a community that were getting lots of cancers because of some version of chromium that was being leaked by a chemical company.
Isn't that also a movie with Mark Ruffalo where he's also a lawyer? But I think he's investigating DuPont chemicals, but I think for like toxic waste dumping.
I think there's also an example of this in the UK. I think it was to do with dust from a mine, and again the community had to kind of prove that this dust was making them ill and causing childhood diseases. So I guess it's not as clear cut in the UK as well, although that was a while ago, so maybe we've learned from that in the intervening decades.
Yeah, there are quite a few. There was a TV series recently, I think it came out last year, with Jodie Comer, that was about very poor health and safety when disposing of toxic waste when they were clearing out an old steel mill in the Midlands.
And yeah, that's not to say the UK and Europe don't have safety breaches. You know, it's like the sewage releases into the waterways. But we have, I suppose, regulation that we can then use to hold companies accountable.
Yeah, and it sounds like because we have this quite strong safety culture, it's probably I assume it's a bit easier to do than it is in the United States. But then again, we also have a decent national healthcare service that would be burdened by lots of people getting ill.
Yeah, but also in the US, companies, industry, they do have a really strong grip on policy and governments just because, like, the way political parties get funding is very different to how it is in Europe. So, like, these companies can literally get the ear of the people in power.
Oh, wow. And I think what I've learned from all the years we've been talking on this podcast is I really don't like that idea. I'm more of a community-spirited person rather than corporate greed person.
And we have limits on how much money can be given to political parties as well. So it has to be in the public domain and has to be recorded. So, you know, there are checks and balances to hopefully stop that kind of going out of control. Well, we're not really talking about chemical safety and testing anymore. We obviously discussed there are measures in place to prevent harmful products from entering the marketplace, at least in Europe. And not to be too negative actually about the US, because there is the Food and Drug Administration, the FDA. And so often people would specifically put on a product that is FDA approved.
That is true. Just that what the FDA would approve, their standards are different to what Europe would approve through things like REACH or through other like country-specific legislations.
So going back to the article I was reading about childhood diseases and how they seem to be increased by chemicals that are assumed safe. Is the FDA slightly more relaxed than we are in Europe and the UK, or is that not a very nuanced summary?
I don't think they're more relaxed. I just think legally what is required in the US is different. So, like, there are some chemicals in US products that are banned outside.
But the reverse is also true. So there are some food additives that are allowed in Europe that are banned in the US.
Yeah, so I guess it's like weighing up the pros and cons of like who takes safety and toxicity more seriously and like who does it better.
I tried to go down a route of looking at numbers, what we call flavourings and additives in the UK, and they have a whole list of which are allowed in the UK or Europe versus what's allowed in the US. And there are some interesting stories, like one of the colour for red is banned in the US because it was made from coal products. It is allowed in the UK and Europe, and we use it in glacier cherries.
I mean, is there a medical reason why a coal-based product is bad?
Carcinogenic and possibly other harmful effects.
Okay, but does that depend on concentration?
Yes, so that's something that the Europe has defined as like certain limits of how much you can use. Whereas I guess if you totally ban it, you don't have to worry about a safety limit.
I wonder, this is me being really skeptical again, if in the US they assume that everyone eats junk food, so they're consuming vast quantities of E-numbers, whereas in the UK we're less likely. That is an incredibly skeptical point of view, though. Don't take that seriously.
Well, since we have moved quite far away from chemicals now, I think this is a good place to leave it. We did discuss how there are tests and standards for regulating chemicals and products, but there is also a limitation to how much we can know about every single substance, and there are relatively new concerns like bioaccumulation that it just kind of takes time to learn about. If you enjoyed this conversation, I hope you'll join us for another episode. Thanks for listening.
The views expressed in this podcast belong entirely to the person that said them. They do not represent any industry or organisation. If you enjoyed listening to these views, it would really help us out if you could rate us, leave a review and tell a friend. This podcast was sponsored by no one, but if you're interested in funding us to continue to have frank discussions about science and engineering, please get in touch.